So Assalamu alaikum Mohammed Ran. Since we have discussed the
Alaikum
whole
salam.
life cycle, now you have to tell me what we have discussed up till now. So the first section
All right.
is you have to explain me what is PDLC, and you have to explain me each step what we have discussed up till now. Okay, now you may start.
Okay. So I'll start with problem definition.
Okay.
So problem definition is like you define it as you define the like for yeah, like you take out the average basically. For
Yes.
example, there's like five students in one class, and then you want to find a total average of it. You can divide it by the you can divide each person by total number of classes for to find the average. Okay.
Yes.
All right. So that's problem definition. And then for analysis, it's basically you identify like if there's a like you identify if there's a problem anywhere, or you analyze it, and then you start
Dividing it.
like dividing it. Yeah, yeah, dividing it basically.
Yes.
All right. And then algorithm design is basically like you start to design what you're gonna make basically. For example, you're gonna go with like pseudocode, but you won't go for like fully pseudocode basically.
Yes. Yes. Absolutely
Yep.
right.
All right, and then you go for like the flowchart slash pseudocode. This is like with the design stages. You'll start to make like a flowchart and what are the tasks that need to be completed,
The picture of the
and
problem in your mind,
picture
basically.
of the problem. Yeah, yeah, yeah. That's that, and then you go overhead coding where mainly this is the most like mastermind of it. This is like the key to the program development life cycle.
Yes.
Coding. It can be any Python, C, plus Java, anything.
Yes. Absolutely right.
All right. Yes. And then after that, there'll be testing and debugging. Testing is like once like the overall program is like set, they're like they'll be tested, and if there are any problems, they'll be debugged.
Yes, absolutely right. Now, what
Yeah.
documentation? Tell me about it.
Documentation. The documentation is like how do I say this? It's like after testing and doing everything, you will like maintain it.
Yes, yes,
Like
yes.
yeah, you'll do that. Yeah. And then once everything is settled, at the end, if you want to try to update your program, you'll go ahead like at the end after the in the maintenance area. If you want to try to update it, uh, in of the program, it will be there. It will be like the last
Yes, yes. What now explain me about the maintenance part.
maintenance. Okay. Uh, maintenance.
Yes. I told you that
Okay.
we have to add
So
some
yeah, yeah,
feature of stuff like that.
yes. If the programmer wants to like add any after like making everything, they'll need to have an update. So make it like run fresh.
Yes,
Okay.
yes.
So they'll be updating and they'll maintain the program they have created.
Yes, yes, yes. Okay. Now I think I hope everything is clear and you have
Yes.
depicted everything. Now let's jump to your book, I would suggest, so that we could basically see what we was trying to discuss. So let's come
All right.
towards the program development life cycle. It's 7.1 of your book.
Okay.
Since your book can clearly see, let me try open book in front of you so that you can see it more easily and clear. Okay, Muhammad Ayan's book. Here comes your book. Now you can see the screen.
Yes.
So let's see. Since what we discussed was the program development life cycle, so I have explained you the detailed life
Yes.
cycle. Okay, but
Yep.
your book only explains four major steps. Since okay, but I have tried so that you have the overall the practical life cycle in your mind. But since your book explained the four, so I have explained you more about these four sections majorly. I have just
Yeah.
briefly told you about some others. Okay, since
Okay.
I have to teach you what is relevant to you at your level. In upcoming classes, you will move or in more in depth of these concepts, and I'll guide you if I would be available. Okay,
All
so
right.
our the first section was when we try to see the original diagram, you can see we define the problem. So
Yeah.
since it's very obvious, we have to define a problem that here. Then basically what we have to do, we have to do the analysis of that problem. So what your book says basically is that before any problem can be solved, it needs to be clearly defined. Since we also discuss about this, that problem definitions, it's the book is telling you about the definition of the problem, that before solving anything, it needs to be clear what we are trying to solve, what is the main problem. Okay,
Okay.
am I audible now?
Yes, yes, you're audible.
Okay, so before any problem can be solved, it's need to be clearly defined, we know that. And this is called requirement specification or problem definition for a program in our language, what we have discussed. So analysis stage uses the various tools to identify what exactly is required from the program. So abstractions keeps the key element required for the solution and discard the unnecessary details and information that is not required. Okay, it,
Okay.
basically this line is trying to show when we define a problem, so that we are more focused, we will avoid other things, other ambiguities, we will just focus on the problem what we are trying to solve. Okay, we will discard
Okay.
all other things, that where this problem will be implemented, for example, who will use the program, why I'm writing this program. Okay, we are just focusing
Okay.
on the program, the problem, and what we are trying to solve it. We're trying to write the code of that. Okay, so here
Okay.
comes the next step, that is basically designing that problem. Okay,
Okay.
so program specification from the analysis stage is used to show how the program should be developed. When the design stage is complete, the programmer should know what is to be done. Since we have defined the problem, we have did the analysis. Now what we have to do, we should have a graphical picture. We should have picture of that problem. It means that all tasks need to be completed, how each task is to be performed, and how they will work together. It means that how the flow chart, basically what we discussed, we have to design the structure, we have to have a clear picture of that problem in our mind, that first we will take the input, then it will be processed, then it will at the end it will give the output. Okay,
Yep.
so
Yes. Okay.
it comes in the designing part. So here comes our the main part, that is the coding part is, since everything is set, we know what we are trying to solve, we know the overall pseudocode, overall structure, overall flow chart, overall design of the problem. Now what we have to do now, the main thing is to code that program. So program or set of program is developed. It means we now what we are have coded our problem in various languages. It might be Python, C++, Java, anything, any coding language. Okay, we have to code that
Okay.
problem. So each module of the program is written using a suitable programming language. Okay, since we
Okay.
discussed, and what at then what we did, we have to test that if there might be some error. So this is called the iterative testing. It means that the modular tests are conducted, code is amended if needed, and tests are repeated until the module performs as required. It means we will keep testing until our program, our goal is achieved, until there is no error, until we have debugged everything. We have to keep testing. Okay,
Okay.
so what is testing? The main, after coding we have to test the program completed, or a set of program is run many times with different sets of data. This ensures that all tasks are completed and they work together as specified in the design. Okay, so
Okay.
testing basically means we defined the problem, we did analysis, we just designed the problem, then we coded the problem, then we tested the problem. If there was any error, we debugged the errors. Okay, so
Okay.
we have ensured everything that our problem is being totally fully addressed, so that we can fully tackle it.
All right. Yes.
Okay, so this was in the life cycle over. Okay, now I'm
Okay.
jumping towards the diagram I made for you. Now you can clearly see that we have discussed three, four major parts discussed in your board. Meanwhile, we have also discussed the other parts which are not separately explained in your book, but they are written in the sections as well. You can see there are some lines about definition as well. There are lines for some testing as well.
Yes.
Okay.
Yeah.
Now
Okay.
I think now I hope the things are clear regarding the
Yes.
program development. Okay. Everything. If there are
Okay.
any curious, so tell me
Mm,
out. So we will discuss that.
no. No, sir.
All set.
Yes. All set.
So allow, take a deep breath and give me 1 minute. Then we will start our next topic. Revise
Okay.
it. Ended.
Yep.
So let's come to our next topic. This is a diagram of it.
Okay.
So, uh, your book, the next topic I guess is the computer system and the subsystems. Okay.
Okay.
So we have discussed about what is computer system overall. We discussed in our first lecture what was software, what was hardware, okay, what
Yes.
was the
Yep.
data,
Okay.
and what was the user. So it is related to
Yes.
this. Okay, no, nothing,
Okay.
some rocket science. It's very simple and easy. So our
Okay.
computer system is divided into various subsystems. Okay, it means the parent is the child, parent is the computer system, and its child are its various components that collectively make this computer a computer system. Okay,
Okay.
so basically computer system is divided into subsystems. So there are various subsystem of a computer system. First let's discuss the hardware. Okay, since I told you that hardware, anything we can touch physically. For example, we have
Yes.
mouse, keyboard, screen, printer. These are all hardware subsystem of a computer system. Okay,
Okay.
now we have also discussed in our first lecture about the computer, about software subsystem. So software, anything that can't be touched, but it coordinates with the hardware to run the computer. So basically it was the set of programs. Software was basically the set of programs that was
Program.
okay. It was a big
Okay.
program. We also discussed about various application softwares. We discussed about other softwares in our previous lectures. Okay, we
Okay.
discussed about the application software like WhatsApp and stuff. We did we discussed about the system software. You remember, it was the operating system, it was the
Yes. Yes.
users,
Yeah.
it was the databases, it was all the system softwares and application software. We have discussed it. Okay.
Yes. Okay.
Now comes the data subsets. So our computer has lot of our computer deal with lot of number, a lot of text, we have lot of images in our computer. Okay, we have lot of data.
Okay. Yeah.
Like this is a picture in front of you, this is also saved in my computer, so it's part of data. So anything that is
Okay.
stored in my computer is part of data subsection. Okay,
Okay.
let's come towards the users. I know your book discuss only three or more major parts, but I will also discuss these not so much thoroughly. We will just thoroughly discuss what's written in your book, so it becomes clear to you. Okay,
All
and
right.
I'm explaining you a bit more things for your conceptual base, so that you understand more things, because upcoming lectures would be more relevant to other structures. You should at
Yeah.
least know what the computer system
Yep.
is. So let's come to the
Okay.
users subsystem. Okay,
Okay.
so user subsystem is basically the user who use the computer, like you and me. We all are part of user subsystem of a computer.
Okay.
If
Yes.
we are programmers, if we are teacher, if we are students, whosoever who is using the computer comes in the user subsection. Okay,
Okay.
there are other like procedures. Procedure systems are the set of rules or steps for using the system. For example, when you on your laptop or computer, you put a password, then your system is on. Okay, so this all comes like login procedures,
Yes. Yes.
logging into your computer. It's a procedure, so it all comes in the procedure subsystems. Okay, and the
Okay.
last is the communication subsystem. So basically communication is to communicate. Since I am teacher and you're student, we are communicating with each other. So all these sort of things we are communicating via internet.
Yes.
So it is all comes in the computer system of us. Okay,
Right.
so
Okay. Yeah.
these all things collectively makes a computer. Okay, see, these all subsystem, these all childs mix up to make a computer system. These are
All right.
all subsections, subsystems of a computer that collectively, work together to make a computer system, a complete computer system.
All right.
Now I will refer to your book. You can open your book.
Okay.
So first come on the computer system 7.2. It says that a computer system is made up of software, data, hardware, computer, and the people or users who use it. So each computer system is divided into various subsystems. Okay, each subsystem can be further divided into subsystems and so on until a subsystem just performs a single action. It means, you can see that we have divided into just one level system,
Yes.
computer system. To we can also divide every step into more steps as well. For example, here we can divide communication into more subsystems, and that subsystems into more subsystem. We can do it, but we are discussing everything on the large level, on the upper level. We are not going into the inner complexities of this whole subsystems. Okay, so this
Okay.
is,
Yeah.
so it means the book is just trying to say that we can also subdivide your subsystems as well. Each subsystem can also be
Yes.
divided into other subsystems until a system is achieved that performs only one action. Okay, so
Okay.
it's just saying that we can divide the parent into the child into grandchild, and that grandchild into the super grandchild, and so on until no one is left
Okay.
and Qiyamah is achieved.
Mhm.
So computer system is, the next line says, the computer system can be very large or it can be very small or any size. Okay, blah blah blah. These are all things you will understand it easily. For example, when you wake up in the morning, it's like a story, blah blah blah. You just read it
Yeah.
yourself. Okay, so let's come to the computer system and its subsystem 7.2.1. So in order to understand how computer system is built up and how it works, it is often divided into subsystem. So this division can be shown, this all theory, you when you will read it, you will understand everything. Okay, nothing some. So
Okay.
just I'm just trying to explain one highlighted line, that is the top down design. So top down design is basically we are seeing everything from upper level, then we are moving into the inner complexities of everything. Since we will we know what is computer system, then will we then we divide it into subsystems like hardware, software, blah blah blah. Okay, then we can
Okay.
also, so we are seeing, we are going into the depth of everything from top to down. Okay, from
Okay.
computer to its subparts, then subparts to super subparts, then super subpart to super subparts. So it's top to down approach. So it's
Okay.
just,
Yeah.
yeah, so but we are just decomposing a computer system into other subsystems. Okay, we are
Okay.
breaking into, so this is known as our top to down approach, we can say it. The book is just trying to
Okay. Yeah.
explain it.
Yes.
Now take a deep breath, and we will be moving towards our next topic, that is decomposing a problem. Okay,
Okay.
so 2 minutes break.
All right.
Dead. So Ayan, the next topic is
Yes.
decomposing a problem. Are you there? Everything all set?
Yes. 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 All set.
So since the line shows, the keyword shows decompose a problem, it means we are breaking our problems, our complex problem, into smaller sub problems basically, and that,
All right.
and then these sub problems join together to give a combined solution.
Okay.
It's just
Yep.
like problem analysis, in which
For
what
like for like easier understanding and like
yeah,
solving it, right? Okay.
yes. But what we did in our problem analysis section, we basically break our complex problem into smaller parts, then we solve that smaller parts, and all their individual results combine together to form a combined solution of our complex problem. This is what
All right. Yep.
decomposition of a problem means. Okay,
Okay.
decompose mean to break. Decomposition of a problem means to break problem into its parts or subparts. Okay,
Okay.
since I also made a diagram for it, I'm let's trying to show it. just finally I am good at making diagrams. Let me show it. You can see it.
Yes.
So what we did, it was a complex problem. We broke it into smaller parts, smaller sub problems, and these all smaller sub problems results combined together to give a combined solution of that problem. Okay.
Okay. Yes.
So now let's come to your book. Your book says any problem that uses a computer system for its solutions need to be decomposed into the component parts. Okay. So the
Okay.
component parts of any computer system are, so it has, the book has divided your problem into four parts, major parts. It has divided into input part, then process part, then output part, and then the storage part. So these are four major parts. But your book did it. Your book did it by breaking problem into four major parts basically. You can
Okay.
use
Yeah.
this convention as well, but
See.
you can you break the problem as per your convenience, since your problem might be much bigger that you have to divide your problem even into 10 sub problems. Okay. So it
Okay.
depends upon the programmer, it depends upon the problem as well basically.
All right. Yes.
But
Okay.
conventionally, in general, we can divide any problem into four major steps. So the first is the input section, the input and component of problem. So we divided problem into four major parts. The first part is the input part. Okay. So the rule
Okay.
book says that in the input part, the data used by the system that needs to be entered while the system is active. So input part, as the name shows, input, something has to come inside the problem. For example, if you are trying to calculate the average of 5 students, so the marks of 5 students need to be entered in the program, okay.
Yes. Okay. Yes.
Not a rocket science. So next section is the process. So since we have taken the input of 5 students, now we have to process that 5 inputs. Okay. So
Okay.
the process part is the task that needs to be performed using the input data and other previously stored data. It means then the marks we have taken as input needs to be processed. It means the problem we discussed, that we are trying to calculate the average of 5 students. We take the input of 5, we take the marks of 5 students as input, then we process it.
All right.
Per-
Okay.
what we
Yes.
did, that we applied formulation in this part. We applied the formula to calculate the average, and now the average is calculated. Now let's come towards the next part, that is output. Since we have taken the input, we have processed it, now what we have to do, we have to do the output of the average. So
Okay.
the output section of our problem will give the output, the information that needs to be displayed or printed. Okay. So in our
Okay.
case, what needs to be printed, tell me.
Printed. It should be these sub problems, right?
No, I'm talking with the reference of average. What needs to be printed at the end?
Of average.
Yes,
The answer.
the answer, and
Right.
the answer is average itself.
Okay.
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 So we take
Yeah.
the input of 5 input marks of 5 students, then we process it. It means that we calculated the average. Now what we have to do, we have to output that average, what we have calculated.
Okay.
Okay.
Yep. Okay.
So
Yep.
since we have done everything, we have taken the input, we have processed it, then we have output the result, that was the average of 5 students. And then what we have to do at the end, after doing everything, we have to store it somewhere in the
Store it.
computer.
Yes.
Okay. So the
Okay.
data or the output that needs to be stored in the files on the appropriate medium, so that we can use the same thing in the future.
Okay.
Since
Yes.
your teacher asks you to write a program to calculate the average of 5 students one day, and 1 week later she told you, she tell you to write again, you will not write it again, you will say it, I have saved it somewhere else in my computer, and you can easily show it. So
Okay.
it helps
Yes.
us to
Yes.
for the future use.
Future. Yes. Okay.
So that was the overall structures.
All right.
Let's you can see the next page, the structure diagrams.
Yeah.
you can see the hierarchy, the parent child relationship. The system was divided into subsystems, and every subsystem can also be subdivided. Okay, you can
Okay.
see it
Yeah.
while seeing the diagram. So every subsystem can be further divided, it means you can see the diagram. It just
Yes.
trying. So first, let's also discuss 7.2.3 methods used to design and construct a problem. Okay, so solutions to problems need to be designed and developed rigorously. The use of formal methods enable the process to be clearly shown. So why we are trying to creating the flow charts, the structure diagram and pseudocodes, so that our process, our problem can be clearly shown, that what we are trying to solve.
Okay.
After
Yes.
seeing the diagram, we can easily see what is going to happen, you know so
Yes.
overall, the overall reason why we did not just code the problem, why we made the pseudo codes, why we make the full charts, so that we can clearly see our problem, we can clearly know the steps of the problems. That was the main reason, na?
Okay. Yes. Yeah, it is.
So what we did, the following methods needs to be used by fla computer science students. देखो, your last suggestion was from your book is the following method needs to be used by the IGCSE computer science student is to draw the structure diagrams before coding,
Yeah.
draw the
Yes.
flow charts before coding something, and write the pseudo codes before writing the codes. Okay,
Okay.
so this is a good practice always, but since when you
Yes.
will get more experience, you will be efficient enough, to just you will just think a problem, then you will do everything in your mind itself, you do nothing to write. Okay,
Okay.
you will create a picture automatically in your mind, then you will automatically create a pseudo code in your mind, then you will directly implement the problem. That is what we do. Initially what we did, I also used to draw the pseudo codes, I used to write the flowcharts and everything. Now I'm experienced enough, now I'm efficient enough that whenever a problem come into my mind, in front of me, I just code it directly. So these things come with
Okay.
experience, but you
Hmm.
never know if the problem is still, if there is any problem that is still very complex for me, so I also use these steps. I also divide it
All
into
right.
small
Yeah.
problems, into sub problems. Then I solve it, and then I collect, derive a combined solution from that problem. So this is a good practice, and you will always follow these practices in order to ensure that you write a very good program, and you can solve every problem of the world. Okay.
Okay. Yes.
Okay.
All right.
So I think this was our today's topic. We have discussed two or three sections in it. What we discussed, our as a practice, we are always revising everything what we have discussed today.
All
Today
right.
what
Yeah.
we discussed about the program development life cycles. We we defined that we should define the problem before doing something, then we have to do analysis of that problem, we have to design the algorithm, then we have to draw the flow chart, then after doing all this thing we will basically code the problem, and then we after coding we will test if our code is working or not. If there is any error, we will debug it, and after doing all these stuffs we will document it, and we will
Okay.
maintain it. If in future we have to add some feature, we have to upgrade our code, this all things
Yes.
will come in the maintenance part. Then we will when then we discussed about the computer system. But we discussed that our computer system is subdivided into various subsystems, that is hardware subsystem, software, data. We individually discussed it, and we also read it that we can also subdivide these subsystem into more subsystems. It means we can divide hardware into more hardware subsystem, then again, and so on. Okay, so
Yeah. Okay.
every
Yeah.
subsystem can be further subdivided, we discussed it.
Yes.
Then at the end what we
Mm.
discussed, that decomposition of a problem, it means to divide the complex problem into smaller sub problems, so that it becomes easy for us to solve a complex problem, since we divided that problems into small parts, and then we solved each small parts, and their collective solution becomes the combined solution of that complex problem. Okay,
Okay. Mm.
So, and what we discussed it that it is a good practice to always, draw the structure diagrams, flow charts, and pseudocode before solving any problem, before writing any program, before directly doing jumping into the coding section. We always what we have to do is to draw the flow chart or write the pseudocodes. Okay.
Okay. Yeah.
So see you next week in our upcoming lectures. Since
Mm.
our working days are Tuesday,
Mm.
Wednesday, and
Thursday.
Thursday. Yes.